So this question is lowest common ancestor of a BST. So given a BST, you want to find the lowest common ancestor node of two given nodes. And P and Q is going to represent like two nodes in the tree, and then you want to return what is the lowest common ancestor. And let's look at this. Clean this. Alright, so 2 and A. So 2 is going to be here, A is going to be here. So you starting from the root, and you want to traverse. Does my two children, P and Q, is two children is on the left or the two children is on the right? Like these are two scenarios, right? If you cannot satisfy this scenario, you are return yourself. This might be the reason why this is the lowest common ancestor, right? Because it's either both of them is on the left or both of them is on the right? So you want to starting from here, you want to traverse, checking your P and Q value, and then basically traverse left and right. And this one, let's look at this. P equal to 2, Q equal to 4, right? Alright, so it's starting from here. And then we know that P is what? P dot value is less than the node, right? Root dot value, and also Q dot value is also less than root dot value. So we move our, the current node to here. And then we're going to check, does my P dot value less than root dot value? Does my Q dot value less than root dot value? So we notice that since P equal to root, we can actually know this is the lowest common ancestor, right? So we will return this guy, like this root. And P2, okay, doesn't matter. Alright, so this is like a tree traversal, and then you want to know how you traverse, but basically. So here are two solutions. One is recursive DFS, and the other one is iteration. I mean, it still look like DFS, but whatever. Alright, so what do I need to check? So if root dot value greater than P dot value, and also root dot value greater than Q dot value. Alright, so this guy is a root, and then P dot value is less than, right? Q dot value is also less than. So we move to the left, return this guy root dot value, and Q and P and Q does not change, right? So this is one scenario. The other scenario is going to be the other direction, right? And this has to be right. Alright. The last scenario, it doesn't mean that it doesn't matter that one is on the left, the other one is on the right, one on the right, the other on the left, or one is actually the root itself. You will just return root. This will secure that this is the lowest common ancestor, right? So this is how it is. So the time and space, time is actually what? So once you go left, you don't need to go right. So you cut the tree half, so it's going to be log base height, right? So height will be all of h, right? And you can say log n depend. It actually depend on the tree, like how many nodes in the tree, and then this will be one of solution. I'm asking this kind of solution as a DFS. There might be another solution look like this, but I don't care. Alright, the next solution is going to be iteration. Still going to be the same, but using the while true condition. And instead of calling the function itself, we actually change our root. So if root dot value greater than P dot value, and also root dot value greater than q.val, and then we actually change our root to root.left. And then this is going to be else if root.val less than t.val and root.val less than q.val, and then I'm going to change my root to root.right. And last scenario is going to be what? Return root, right? And this is going to be return no, something like this. Like you need to return something. Return no, should be okay. Oh, did I make this something not looking? Oh, okay. So just find out, like, even though you place over here, it is actually the pattern. I mean, the pattern is still correct, but this is unreachable statement because this is while true and I don't have a break. So you can get rid of this and then you can run it, and then yeah, you'll pass. So I was thinking of what was happening, but whatever. Alright, so while true, and then this is how you traverse, right? It's either go left or go right, or you'll return yourself, right? So this will be in iteration solution, and the time and space is going to be the same. So you either cut the tree half to the left or right, right? So it's going to be all of h depending on the height of the tree, and space is constant, all of 1. You not allocate any space. So this will be a solution, and I will talk to you later. Bye.